Hi, I am Gaurav and welcome to my channel Code with GT. In this video, I am going to tell you how to scale a system. What are the different ways of scaling, what are the pros and cons of each approach, and at the end, I will tell you which approach is right for you. So let's get started. Let's say you have an application running on your computer and we have different people who are using the application. So they send some request to your application and your application sends them a response. Now imagine a case where a lot of different people start sending you requests and this application is at the end hosted on a machine. By machine I mean on a computer, and when lot of requests start coming in, this is an indication that you need to increase your machine. This is what we call scaling a machine. Increasing the ability of your system to handle more requests is called scalability. And in computer terms, when we talk about scale, that often indicates the number of incoming requests. Now there are two ways to increase your system capability. One way is you create a bigger machine. Let's say my previous machine was smaller. I make it bigger in size. By bigger I mean we can increase the machine specs like more RAM, more storage, more number of cores, more number of threads so that it can handle more incoming requests. So after I increased my machine, it can now handle more user requests. This is what we call vertical scaling. Another way to increase my system is create more machines. This will also increase my system capabilities to handle more requests. And since we are increasing the number of machines, we call it horizontal scaling. So what are the differences between these two approaches? And how is vertical scaling different from horizontal scaling? Let's look at it. Let's look at key differences between both of these approaches. For vertical scaling, I had created a bigger machine, whereas in horizontal scaling, I increased the number of machines. Whereas here I had more machines. So in a bigger machine, all the requests are directed to this one bigger machine, whereas in horizontal scaling, how do we decide which request goes to which machine? For this we have something known as a load balancer. This is a load balancer. This will take all the incoming requests from the user, and this load balancer will decide to distribute the requests to each machine. It will balance the load such that no machine is overwhelmed with requests. So this is more of an intelligent layer. So this means load balancer is required for horizontal scaling, whereas for vertical scaling we don't need it. We all know an application reads data and the data is stored in a database. Now there will be a single database which will store all the data, and in horizontal scaling all the applications will read from that one database, whereas in case of vertical scaling only one application will read from that database, and it will not only read, it will also update data in the database. So in vertical scaling, update will happen only for one application, whereas in horizontal scaling, updates can happen simultaneously from different applications. What this introduces is some data inconsistency in the database. What multiple sources of updates mean is there will be race condition during these updates, and the race condition introduces data inconsistency with the data. So we can say vertical scaling is more data consistent, as in we don't have any data inconsistency, whereas in horizontal scaling there are chances of data inconsistency. Now data inconsistency is also affected by the type of database you are using and how your application is interacting with your database. But assuming like all those factors are not in play, chances of data inconsistency are more in horizontal scaling when compared to vertical scaling. Coming to the next point, in vertical scaling, there is a single point of failure. Assume my application goes down In that case, none of my users can make the requests. So we have a single point of failure in vertical scaling, whereas for horizontal scaling, if one of my applications goes down, let's say this application goes down, the load balancer can redirect those requests to a different application that is up. So horizontal scaling is more resilient in that manner. In case of vertical scaling, there is some limit based on how big you can make your machine. Whereas in case of horizontal scaling, if your users increases, you can increase the number of machines and scale your system. Hardware limit indicates the size of the hardware, like the size of the storage or size of the RAM or even size of the cores in your processor. They keep on increasing with advancement in technology, but there's a fixed limit to that. Now these are the key differences between horizontal scaling and vertical scaling, and you need to keep them in mind while scaling up your system. So which type of scaling should you use for your system? Well, there's no one right answer. System design is all about trade-offs. For example, if you're just starting out and your application is small, vertical scaling makes more sense because you don't need to worry about data consistency problems. Whereas if your application is growing and you are running your code in multiple machines, you need to code in such a way that the chances of data inconsistency reduces. If you want your system to be highly available, you should go for horizontal scaling as it is more resilient, whereas in vertical scaling, if your system goes down, none of your requests are served. Now, one of the demerits of using a horizontal scaling is you need to invest in a load balancer. So if you're starting out and you want to keep things simple, it's better to go for vertical scaling. If you have resources, you can go for the load balancer setup. These are some of the points you need to consider before choosing which type of scaling you need to go for. So that's it for this video. If you learned something new, like this video and share it with your friends. Don't forget to subscribe to my channel Code with GD. Till then, happy coding. Bye bye.